Hi students and welcome to T-Rex Math. Yesterday we explored how you can use a chip model to represent addition and subtraction. And before you left for the day, I had you fill in the back of your exit ticket that had the following problem. Pause this tutorial and make sure you have your exit slip from yesterday. When looking at this problem and using a chip model, the first thing you need to do is set up. When you want to set up a chip model of this, the first thing you would need to indicate would be 3 negative chips or 3 red chips. If you want to take away 8 from 3 negatives, that can't be done because you don't have 8 to take away. Oh, shoot. Three red chips for -3 as shown here. If you want to take away 8 from the -3, you'll notice you can't do that because you only have -3 chips. So you need to create an additional 5 0 pairs as shown here, because this would really be a -3 and zeros, which still keeps the value at -3. When you create the 0 pairs, it allows you to take away the 8 positive I messed that up. So what you'll want to do is add 8 0 pairs. By adding 8 0 pairs, you still have -3 plus 0, which is a -3. But by having the 0 pairs, it allows you to take away 8 positives. So we want to go ahead and cross off 8 positive values. And then we're left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and they're red. So our number sentence would be -3. Take away 8 would be a -11. You might also think of this using a number line like we've looked at in the past. If we're saying that it's -3 take away 8, we're going to start at a -3, and then we're going to move back 1, 2, 3, 4, 5, 6, 7, 8, and we land at -11. So our number sentence remains the same as what we got with the chip model, but another method that you are okay to use. Because we might not always want to use a number line or a chip model, we want to start to think about algorithms, okay? A plan or a series of steps for doing a computation. So when we think about the chip model versus the number line, when we think about a problem like -3 take away 8, you might notice some patterns that happen. Okay, likewise, if we think of something with addition and you think of a -2 added to a 5 or a -3 added to a -6, you're going to start to see some patterns. For example, I might notice since 5 is further from 0, I can really just subtract 5 minus 2 and get 3. And in this bottom example, if I notice that I have a loss of 3 and a loss of 6, I can really just add the two terms together and replace the symbol with a negative. These are algorithms. They're patterns, rules that you notice that work when using a chip model or a number line, and eventually you won't even need a chip model or a number line. So go ahead and divide up your notebook into 4 sections. So in the first section, you're going to write task number 1, part A, page 32. In the second section, you're going to write task number 2, page B, or part B, page 32. Task 3 is part C on page 32, and task 4, which is part D on page 33. Today in class, you will have 7 minutes to work through each of these 4 tasks for a total of 28 minutes. After you've divided your notebook into 4 sections, you're going to want to turn to page 32 in the binder, and you're going to want to spend your first 7 minutes on task number 1, which is part A. In that task number 1 box, you're going to write your answers to numbers 1 through 4. For task number 2, you're going to write your answers for part B, numbers 1 through 3 in that section. For task number 3, you're going to write your answers for number 1 through 4 in the task number 3 section. And finally, in the task number 4 section on page 33, you're going to write your answers for part D, numbers 1 through 4. So get your math notebook and get started. Make sure you record all your work in your math notebook. And as always, sit where you can be most productive. See you soon. Mrs. Reckamp.